10.4 notes, polar coordinates graphs, page 4. This page is all about lines, not addressed a whole lot in this text. Just want to make sure that you recognize these equations when you see them. So example 6a, we're talking about a line through the pole. And notice that this equation does not have r in it at all. It's just theta equals a, where a is some angle. So let's get that in here. So let's think about what this is telling us. So theta equals pi over 3. That means the angle is pi over 3. Doesn't matter if r is positive or negative. So r could be positive 10, 5, 3, 2, 1, or negative versions. It's going to be the angle that goes through the pole, or sorry, the line that goes through the pole at the angle pi over 3. B is a horizontal line. So we're not used to having the r and the theta on the same side. And that causes a little bit of a problem for us. So let's do this. We go r equal a divided by the sine of theta. You know what? We're going to leave it the way it is. I don't like that explanation anymore now that I think about it. So what we want to do, I'm going to choose an a that I know is going to be easy to work with. And so we're going to look at this equation first. R sine theta equals 2. And so that means I'm looking for an r and a sine theta that I can multiply together and get 2, not 4. So I'm going to pick easy values, and we'll see that this 2 is a little contrived. It's fairly easy to work with, and we're just going to use this to generalize to other values. So so sine of theta equals 1. Let's see, sine theta equals 1 at pi over 2. So the sine of pi over 2 is 1. If I want to multiply that by something and get 2, I've got to multiply it by 2. So I know I've got this point, 2 pi over 2. So now let's think about the other things that are going to be easy to work with. Sine of theta is 1/2. Where does that happen? That happens at pi over 6, 5 pi over 6. And so I've got sine of pi over 6, there's 1/2. If I want to multiply that by something and get 2, this is going to have to be 4. So I get the point 4 pi over 6 and 5 pi over 6. We can try this with 7 pi over 6 as well. We're going to get a negative 1/2. We'd multiply by negative 4. Yeah. So I've got 3 points that I can use, and so I'm going to plot those. I've got 2 pi over 2. So straight up, 2 away. I've got pi over 6, 4. So here's my pi over 6. 1, 2, 3, 4. 5 pi over 6. 4 as well. And I get this straight line going through all 3 points. Would work the same way if I had r sine theta equals negative 4. Let's pick another color. 1, 2, 3, 4 down. It is going to be, that's interesting, this horizontal line. Okay. Works the same way when we've got r times cosine theta, except this time we're going to get a vertical line. So if I've got r cosine theta equals 3, 1, 2, 3, And then I get this vertical line through that point. Works the same way if we've got a negative. Flirting with disaster here, right on the very edge of our graph. Again, that cosine is our horizontal displacement. This is moving us along the horizontal. And there's page 4.